Hi guys, so I've decided I would solve this problem with you just to show you how to do it again if you need some more help. So we start with this problem, which is we are giving three numbers that sum to 28 and they are within a geometric sequence. So this is the first line here that I've written. So I have three terms, A1, A2, and A3. They sum to 28 and this geometric sequence should be decreasing, which will help me later on to determine the value for R. The arithmetic sequence, which has the same first two terms as for the geometric, but the last term should be 4 minus the one that we were given originally. So our goal now is to find what A1, A2, A3, B1, B2, B3 are. Usually what I do for this is I start with the information that is really obvious, which is that the sum here is equal to 28. So what I would do is go ahead and say, okay, well, first we have the geometric sequence. And for geometric sequence, generally we have that Sn is equal to A1 times r to the power of n minus 1 divided by r minus 1. With this, I would sub the information in. So I know that S3 is 28, so I'm going to have 28 on this side. And then A1, we don't know it. It's one of the things we're looking for. R, we don't have R, but we do know that it's three terms that are being summed, which means I would have R3 minus 1 divided by R minus 1. Now looking at this here, I would like to have a little bit of a simpler version of that. And then the powers of 3 are usually a little bit annoying, but thankfully we have a formula that tells us that r to the power of 3 minus 1 is actually r minus 1 in brackets times r squared plus r plus 1. So what I'm going to do now is I'm just going to expand this thing here and cancel it out with the denominator so that we're just left with the power of 2 instead. So basically the result from this is going to be 28 equals to A1. So like I said, I'm going to expand this. So r minus 1 times r squared plus 2. No, not 2. It's just r squared here. There we go. So r squared plus r plus 1 over r minus 1. So this one's gone, and we're just left with 28 equals to A1 times r squared plus r plus 1. Here we go. So this is as good as it's going to get. We have a power of 2, which is usually easy to deal with. This equation only has two unknowns, and two unknowns is pretty easy to work with. So what I'm going to do here is I'm going to put this in a box. Can we do that? It looks like it. So this is one of the main equations that we're going to have to work with. So here we go. Now what you may notice here that is really important is the fact that this equation has two unknowns. So sometimes in other problems you might get three unknowns. If you have three unknowns, then you would need two equations. In our case, we get two unknowns, so we need two equations. It's always the same number of unknowns as you have equations, which we basically mean we need another equation to deal with this. So we could try to see what else we can do from the geometric sequence, or we can go to the arithmetic sequence and then see what happens. If you're not sure, just do both and see where you get with that. In my case, so what I'm going to do is I'm going to go straight to the arithmetic sequence because I've already tried the first option and I know it doesn't work. And we have two other options. We have the symmetric and the mean properties. So I'm going to go with the mean because here I have three terms and that's what the mean requires as opposed to the symmetric property, which requires four terms. So let's do that. So if I take the arithmetic sequence, the mean formula, if you recall, so since here my arithmetic sequence is b's, so I'm going to have bn equals to bn minus 1 plus bn plus 1 over 2. And then I can sub in for what I have, which are the a's here. So if I do that, so basically here, I don't really have a choice. N is going to have to be equal to 2 because if you remember, the idea of the mean is the middle term is always equal to something that's related to the one before and the one after. So my middle term here is 2. So no options here. So B2 equals to B1 plus B3 over 2. And B2 is actually equal to, so now I just go here and then I sub in. So remember, your goal is to get another formula which only has A1 and R. So B follows an arithmetic sequence, which means there won't be any R showing up there. But if you use A's, then you will. So if you have here A2 equals, so B1 is also A1, and B3 is A3 minus 4 over 2. So now we got all A's, but not A1 and not R. So perhaps what we should do is use the fact that AN is always equal to A1 times R to the power of n minus 1 in a geometric sequence. So remember, even though I'm using the arithmetic mean, the A's here belong to the geometric sequence, which means you need to use the geometric general term. So if you sub in for that, then you get A1 times R equals to A1 plus A1R squared minus 4 over 2. These are all A1s and R's, so that's pretty good. We're happy from here. So let me put a smiley face because this is good. Now we probably need to rearrange it because we have this in this form here. So if we have the other equation in a similar form, so having a number on the left and having all your A1s and R's on the right, we would be able to divide the two equations together like we've done before. So let's do that. So here I'm going to have 2A1R equals to A1R squared minus 4. On the next line, what I'm going to do is I'm going to do plus 4 on each side. So that I have my number on this side, like I said, and minus 2A1R on each side, minus 2A1R, so that this way it's exactly in the form that I need. Okay, so we get 4 equals to, let me put it in decreasing order of powers, minus 2A1R. And then finally plus A1. Okay, that's pretty good. Maybe we should, maybe now what we should do is factor out an A1 because I have an A1 in each of these terms and here I have an A1 that's factored out. So let's do that. All right, so let's, like I said, here we are factoring A1. So we're left with R squared minus 2R plus 1. And we have our second wonderful equation with the same two unknowns. So our last step would be, we now have a system and we basically want to solve it. So this is my second equation, and then I've got my first one up here. So what I'm going to do now is I'm just going to divide them. So I'm going to have the first one divided by the second one, which means I'm going to have 28 over 4 equals to A1 R squared plus R plus 1 divided by A1 times R minus R squared minus 2R plus 1. Here we go. So this is gone, this is gone. This here is just going to be a 7. So 7 equals to R squared plus R plus 1 over R squared minus 2R plus 1. My recording time is about to be over. So for this part, what you're only left to do now is basically solve this equation. So what I would do is multiply this bottom part on this side. So you would basically get 7R squared minus 14R plus 1 equals to R squared plus R plus 1. You would put everything on one side and solve for R. And you're done.